All right, let's solve Advent of Code Day 2 in Crystal. This one was a pretty heavy parsing problem. So let's take a look. Each line has a different game, starting with the game number. Then each game has different subsets of games, split up by these semicolons. Each subset can have any number of blue, red, or green cubes that are taken out of a bag. Now for the first part, what we need to do is figure out which games were valid. So the bag only contains 12 red cubes, 13 green cubes, and 14 blue cubes. So any game that has a subset that had any more than that wasn't a possible game. So an example of that is game number 3. Game number 3 pulled out 20 reds, but there's only 12 reds. So we need to figure out which games were possible based on this bag of cubes. And then we need to add up all of those game numbers to get the final solution. So let's take this input. Last time I just manually put the escape character for the games in here, but I'm going to actually try and figure out how to do multi-line strings in Crystal real quick. Multi-line strings Crystal. There it is, multi-line strings. Oh, okay. Any line can already span multiple lines. Any string literal can span multiple lines. Trailing and leading spaces as well as new lines end up in the resulting string. Okay. Well, we want the new lines to be in there. That's good. We'll just make sure that there's no space in front of it. And we'll just make sure that we trim it as we go. Alright, so the first thing we want to do is just say that the input is actually equal to, well, let's just take this string and do a strip on it. There we go. Alright, next thing we want to do is let's actually just kind of parse out all the games and store it in something. So we're just going to say games is equal to, and let's start by splitting it up by the colon. So we're going to say split by, oh sorry, actually first we need to split it by the line, right? Each game needs to be split into its own game. So then we want to map over that. Actually, I think the data structure that I'm looking for is, we're going to go for a hash. And that hash is going to look like this. Game number. And then array of subsets. Where that subset then is a hash again of how many cubes there are of that color. So something along those lines. So to do that, if we're going from an array to an object, this is where we can use a reduce. So let's use a reduce here. We're going to do reduce, and now actually, because we're not giving it a initial, well, we have to give it an initial condition for the reduce here. So Crystal has this thing called type aliases. And if we didn't use a type alias, let's take a look at what this would look like. So we would have to create a hash and give it, because we can't, because it needs to know all the type information, we need to give it all the information up front. So actually the key is going to be an int32, and then the value is going to be another array of another hash, right, of string and an int32. So that's pretty wordy. Let's kind of break that up into little pieces here. Let's say that, first of all, let's take care of this inner hash here. That's going to represent, what do we want to call that? I guess we'll call that a subset, right? Because this was called a subset of the game, so we're going to call that subset. Subset is equal to this bit. There we go. Next, let's take care of this array here. We're going to say that subsets is just an array of subset. There we go. And then the last one would just be this guy, which will be called a game. Or games, rather. Because it's the entire hash there. So now we can just put in here games.new. Very cool. So for each one, we're going to grab, because it's a reduce, the first one's the accumulator, so that will be games. And then the second thing will be the line that we're on. There we go. Let's put an end there. All right. So now we got to split on this colon here. So we're going to say game and subsets is equal to line.split on colon. There we go. Okay, so the first bit's a little easier. Let's just get the number out because we just need the number instead of the game prefix there. So what we can do here is arrange basically a substring and then take the to integer. So we're going to say game number is equal to game, and let's see how many characters there are here. There's 4 in game and then plus a space there. So we're going to say 5 and then to the end. And then we got to take that and convert it to an integer. There we go. It's game number. Now subsets is now this whole thing, and we got to now split on the semicolon. So we're going to say subsets is equal to subsets.split on semicolon. And then we're going to, this time we actually want to keep the array there, so we can use a map, right? So we're going to map over that. And we're going to take each subset and do some stuff with it. So let's put an end there. All right, so what we got to do? Now we got to split on the comma. So let's do that. We'll say subset.split on comma. Now this time we want to convert this array back into an object. So we're going to use a reduce again. So reduce, and this time we're at the subset guy. So we're reusing this alias here. Say subset.new do. We're going to call this set. And we're going to, so that's going to be the set that we're accumulating into. And we'll call it colors. We're going to call it cubes for each item that's in that list there. Okay. Next thing we got to do is we're finally down to this level, and we now need to split this up into the color and the number. So we're going to say the number is the first part of that, and the color is the second part of that when we do cubes.split on an empty space. And I know this from doing this ahead of time. There's going to be an extra space at the front of that, so we just need to make sure that we strip off the white space before we do anything. All right, now that we have that, we now need to put this back into the accumulator here. So we could do something like set color is equal to number. And that works, but the problem is that this assignment here doesn't actually return back the set, so we would have to do set back there. That works. But I kind of like, and this kind of looks a little weird to me. So instead, and technically, this is less efficient, but we're going to do set merge. And then we're going to take the color to the number. And because set.merge returns a new set, we're golden on that. Okay. So the last bit that we need to do is return back this whole same sort of thing for the games. We're going to say games.merge. And then we're going to take the game number and the subsets. Here we go. All right, so let's take a look at what games looks like now. Puts games. All right, so it's all kind of squashed together, but you can see game number 1, and then that's an array of blue 3, 4, or red 4, and then there's another subset of red 1, green 2, blue 6, and then the last subset just says green 2. While we're at it, let's actually convert this number back to an integer here, since we're going to need that in integer form. So let's see what that did there. All right, that's better. Okay, now that we have that, let's actually solve part 1 now. So part 1 involves kind of filtering out which games are valid and which are not valid. So the function for that is called select, or I should say method, right? And so select then gives you, because this is a hash, you actually get the key and the value. So let's destructure that and say the key is a game, or the game number, and then the value is a subsets, right? And truthfully, we actually don't really need the game as we're doing this filter, right? Because all of our logic is going to depend on just the subsets. So let's put an end to that. And then we're going to say, now we've got to check every single subset, and then we have to check every single color in that subset. So let's start with a subsets.map do subset, put an end, and then subset.map. All right, so what do we want to do here? We want to make sure that for each color in the subset, it's less than a certain value for that key. So let's do this. Let's create a hash called bag. And we're going to say that there were, what was it? Nope, right here. The bag has 12 red cubes, 13 green cubes, 14 blue cubes. So 12 red cubes, 13 green cubes, and 14 blue cubes. So all we have to do now is say, again, this is a hash again, right? So we're going to get the key and the value. The key is a color, the value is a number. And we just have to check to see if the number is less than or equal to bag color. So the nice thing about doing it this way is it's not guaranteed that you're going to have every single color in the bag. Sorry, in the subset. And so if you were to go the other way around and check the bag, you would have to then check to see if if that subset contained that color. But since we're going over all the things in the subset, we just compare it against the bag. We're good. All right, let's put a little space in there. Now there's a method called all. If this will return back an array of booleans, right? So we can just say, let's just make sure all of them are true. And we can do the same thing with subsets. Let's just make sure that all of the subsets are true. And then if so, then we're going to, let's see. I guess we didn't really even need the game number at all for this. So what we could do instead of this is we could just say for all the keys in the games. And then we can just say sum that up. Part 1. Oh, and this is no longer a key value pair because we didn't need it. All right, let's give that a try. See what it does. Oh, okay. Undefined method map for int32. Subsets.map. Oh, I didn't want the keys, I want the values. All right, let's give that a try. Okay. So here's the problem. We actually do need the game number because we need to sum up the game numbers at the end. All right. Okay. So let's instead do select on that. We don't need the game when doing the selection, but we do need to get all the keys at the end here and then add them up. So for our example problem, we should be getting 8. And that's the answer we get. Very cool. So part 1's done. Let's take a look at part 2. So part 2, we basically just need to find, we're given a bunch of subsets here, and we got to figure out which of those subsets, or what is the fewest number of cubes of each color that could have been in the bag to make that game possible. So basically, you need to figure out if we have 3 blue, 4 red, 1 red, 2 green, 6 blue, 2 green. So you need at least 6 blues because that's the largest number of blues. You need at least, let's see, 2 green, 2 green. You need at least 2 green for that one. And then you need at least 4 red. So is that right? Yep, 4 red, 2 green, and 6 blue cubes is the minimum that you need. All right, so we already have our games parsed out. Let's take a look at how we do part 2. For this one, I think we just need it, because we're not actually like filtering it, we're just going to use a map. Do we need the game number this time? What do we have to do? Okay, so what we have to then do with those numbers is we have to take the number of red, blue, and green and then multiply them together to get something called the power. And we take all those powers and then we add them all together. So the game number is not relevant anymore. So what we're going to do is we're going to just say that we only care about the values and then map over that. Okay. Next, we're going to, well, we kind of have to squash all the subsets together. And there is this thing called merge on the hash, but it really only merges 2 things together. But what we can do is we can reduce overall the subsets and then kind of fold them into each other. And the merge method also allows you to, because by default, if it sees 2 keys that are of the same value, sorry, if it sees 2 keys that are the same, it takes the newer value, and then overwrites the previous one. But we don't want that because we want to pick the larger of the 2. So let's give that a try. We're going to say subsets.reduce, and we don't actually need to give it an initial condition this time because we actually want it to start with the first item because we're kind of folding it into itself. So we're going to say set in cubes, and we're going to end that. All right, so I'm going to say set, which is our accumulator, dot merge, cubes. So we're basically taking our two items and then merging them together. But we do need to provide this function. And so the function gives us the key, and both the keys are the same, right? But we don't care about the key. We just want to make sure that the two items, let's call them x and y, we pick the larger of the two. So math.max x, y. All right, now that we have that, that's just going to give us basically the minimum amount we need for that. And now we really only care about the values so that we can multiply them together. You know what? I bet we could, can we do this in one fell swoop? I don't think we can. I think we have to reduce this first, and then after that, grab the values and then multiply them. So we're going to just tack on the values, because that's already giving us a hash. And then there's something called product on the array. Product. There we go. Then we have to add them all up. Put a sum there, and then let's take a look at part 2. What are we expecting? We're expecting for this example 2,286. And that's what we get, 2,286. All right. So I think the cool thing that I learned when solving this problem was, first of all, aliases. That really helped out. One thing I do think is a little strange is the syntax for mapping. What feels natural to me is to do this. But unfortunately, that's actually a parsing error. So this is the correct way of doing it. You have to put a space between that. Actually, you don't have to put a space between that. This works as well. But I think this is more idiomatic. And it looks okay when you do something like that. Because this is actually called something... They look like anonymous functions, but in Crystal they're actually called blocks. And they literally are. Like this looks a lot like this with the end. It's because they're actually semantically the same. This is just kind of like some sugaring added to it. So anyway, that's how I solved day 2, and hopefully I'll be back tomorrow for day 3. See ya.